All right. Hi, everyone. We are filming the coulometry lab today. It's myself and Ingrid here, and we thought it'd be fun if Ingrid sets everything up, and then I take the procedure without having any clue what's going on, and then we just run through it. So we'll figure out how to do the experiment, we'll give you guys the data, and then you guys can use that for your lab write-up.
Yep, formal lab write-up.
For the formal lab write-up, and you guys can also see everything that goes on. So, let's get started. You should have this procedure here if you're following along with us. If not, grab some popcorn and enjoy the show. If you're even watching this, if not, then you should be watching this. All right, so step number one, examine the coulometer. Note that the two outside electrodes, so we're looking at this guy right here. Note that the two outside electrodes are connected to a common post, while the middle electrode alone is connected to the other post. In this experiment, the middle electrode is made the cathode, negative, and the two outer electrodes together serve as the anode. The copper electrodes may be detached by loosening the appropriate thumb screws. Okay, so basically what this means is this post right here, the top post right here, if we flip it around, is connected to these two outside posts right here. And this post down here, this bottom one, is connected down here to this post. Therefore, when we plug these in, these posts aren't connected to each other, and we'll have electricity flowing through our solution. Step number two, clean the electrodes with emery paper. Wash the cathode with distilled water, then with acetone. Caution, acetone is highly flammable, so don't catch anything on fire. So emery paper or sandpaper, we're basically going to sand these surfaces down until they're nice and shiny clean. And then once we're done this, we're going to then sand the copper down as well. And then you want to make sure that you also get, if you guys were doing this, you'd get between these posts right here so that the connections themselves are all nice and clean. Because you don't want any oxidized metal getting in the way of your reaction. Okay, so we've done that. Then we take our three different copper electrodes here, and we're going to sand these guys down one by one until they're nice and shiny.
I can help you out.
So if you see here, here's what the oxidized surface looks like. So you can see here where my finger is nice and shiny. Here it's all oxidized. So,
you know what I just realized? I
What's
think
that?
these are the electrodes that they're talking about, and they would have been set up in the coulometer already.
maybe. There we go. Everything's nice and shiny. We have a lot of copper dust sitting here on the counter.
Isn't this far more fun than actually coming in and doing the lab?
You're asking them?
Yeah.
That's fun for them. I'm here on a Monday now instead of being home eating ice cream, so. Okay, so we have to wash these off now, and the electrode. So, DI water and the electrode. Spraying that down, and then our copper posts.
We're not allowed to touch the surfaces, right?
Of what?
Of the electrodes.
No, we have to hold them by the top here.
Huh? There. I'm gonna put some gloves on.
Yeah, you should probably do that. I wasn't going to say anything, but
Yeah.
Ingrid's in a video without gloves on. You guys should all give her hell when you see her next. Okay, so those are all rinsed off. Bottle of acetone to get rid of the water. Jesus, Ingrid. Ingrid, I have acetone. Oh my goodness gracious. Jesus. You were like the lab partner that everyone was terrified of, weren't you? You'd be like setting stuff on fire.
Of course I did. It's all about safety when I talk to the students. There are some tongs.
Perfect. Okay, so we have those three rinsed. give the electrodes.
I don't know if you're supposed to light that on fire.
This?
Yeah.
I'm not lighting this on fire. This is going to air dry. The copper I light on fire. That'll put aside here. Okay, so grab that. Dry all that off without anything oxidizing.
Let's clean off the ceramic surface.
Oh boy, that's really cool.
Yeah, you don't want to. You're not supposed to heat it too much because
No.
it oxidizes it.
I heated it too much, and now it turned a weird kind of color, and we'll have to deal with that after.
Okay.
So we'll have to sand that one again.
That smells hot.
So just a quick little run through. There we go, almost. There's one done. There's two done. And this guy.
I haven't actually.
Yep. So if you oxidize your metal like me, cool it off with some water. That should be cool.
Oh, and don't try this at home.
I don't think they would anyways. Don't try this really boring titration at home. We're watching you.
I feel like you're supposed to clean the whole thing.
Yeah.
I didn't do that. It's messy.
It's copper. Alright, one more time. Give that a quick rinse. Acetone. And then, oh, there we go. That caught fire.
That was fun.
Should we show that again?
Yeah, that was fun. Hey, watch, or you'll miss it. Woo! Oh, shh.
That's okay. It's just a little fire. Almost. Here, let's put that back. It's almost done.
Okay, I think we're good. Okay, turn off the.
Ingrid lights the bench top on fire.
Yeah, you're the one dealing with the acetone.
Okay.
Okay, so
Hold
the
on, it's my turn.
electrodes-
It's my turn. I'm going with this. You know what to do. I don't. Okay, clean electrodes. Use the analytical balance to determine the mass of the 3 electrodes. So, we're going to take our tongs again, and we're basically going to weigh these guys out. I guess we're not weighing them on any plastic. We're just going to weigh them directly on the plate.
Okay, sure, sounds good.
Okay. Oh, we also have to mark these so that you know which one's which. So assuming that they're dry enough and not boiling hot, then you take your marker, you just go 1, 2, 3. Okay. So electrode 1. Make sure
And
this
look.
is on.
I've set up my lab book for the results. Okay, David.
Okay.
Electrode number 1, mass before.
11.4735.
11.4735. A little awkward, eh?
A little bit. Okay.
Number 2.
Number 2. Just trying to get just the top of this one. Sorry, 13.9964.
9964. 13.9964.
Number 3.
Yep.
$12.9830.
12.9830. 3, 0. Awesome.
Okay. So, weighed all 3 plates. Step 4. Attach the electrodes to the coulometer cover, which is this guy. Okay. So, to attach these, really straightforward. Let's grab number 1, and we're going to attach it to the outside post here. So this basically slides in, and then we tighten the thumb screw here to really lock that in. Perfect. And we'll go number 2 in the middle. So that guy goes in. So you want to try and avoid at all possible to touch the copper plates themselves. If you need to hold them by the side, you can. I guess we can probably use this for next year too.
What?
This video.
Oh, yeah.
So if you're watching this next year, we filmed this because everyone was hoarding toilet paper over Corona.
Not sure why.
Not sure why. Okay, now we take a beaker and fill it up with the electrolyte, which Ingrid's already prepped.
Yep.
Which is a gorgeous color of blue. There's our electrolyte.
And it came from this bottle, which is the copper electrolyte for Faraday lab.
And then this goes on top right there. And it'll kind of plug in a little bit. Perfect. Okay. So now we have our electrolyte solution with 3 copper plates in there, and everything looks good and good to go. So that's going to go down there. Step 5, soak a wad of glass wool, or in this case cotton wool, into an NaCl solution and press it tightly in place at the bottom of the U-tube in figure 1. So we're going to take our...
And just so you see...
cotton ball.
Saturated NaCl.
Take your cotton ball, plop that in there, and then basically we want the cotton ball to just soak up, how am I going to hold this? There we go. All the NaCl solution. Because cotton holds a lot of air, it wants to just float, so you really need to squeeze all the air out of this, because we really want this thing to just suck up all the salt solution.
And until it starts to sink, you know.
Yeah, until it starts to stay down at the bottom, you haven't really done it. So there you go. So almost done. There we go.
Good job,
so as we
David.
can see here, thank you, Ingrid, the cotton ball is no longer floating up. It's soaked up most, if not all, of the NaCl, and we're off to the races. So we're going to take our U-tube.
Haha, YouTube.
Oh, it's funny. Thanks, Ingrid. Good pun. And then we're going to take the plug and holding this over the tube so that when all the NaCl drips out from squeezing it, it's just going to fall back in the beaker. We're just going to shove that in there and then put that guy all the way down there so that you now have your cotton tube, or sorry, your cotton plug in the bottom of the tube. Okay, step 6, make the electrical connections as shown.
No,
oh no,
step
sorry,
5.
step 5. Fill the U-tube with saturated NaCl solution and insert the carbon and iron electrodes. So we have our NaCl solution that we just used, and we're going to fill this guy up on one end.
1 centimeter.
1 centimeter below?
Yeah, so you have to imagine these things fitting in there. That doesn't look good, does it?
So as you add this, the cotton plug might start to move like it did right here. Just shove that back down there. And if you did it right, you should see that the levels of your solution should be different depending on where your plug is. That means that the cotton plug is acting as it should. We can see here this side's higher than this side, which means that our plug is doing a good job of plugging the solution. Because we don't want these two solutions to mix. We want these two solutions to basically stay separate from each other while also maintaining a salt channel. Okay, which one's this one?
That is the iron electrode.
Okay. So this goes in there.
And
you said a
notice
centimeter.
that there's a little
Yeah,
air.
that's our vent.
Yeah, a little
so
vent.
I'm going to turn that so that it's facing the outside.
And this is the carbon electrode.
And this is the carbon electrode. So inserting that.
So we might need to...
So if you see here, the water is touching the plug. So I added a little bit too much. So I'm just going to basically drain.
You know what? I'll get you a pipette thing. So you can just suck it out.
Sure. If you're going to do it the right way, Ingrid's going to want a pipette. I would have just poured this out.
I'm your sous chef.
Okay.
No eating in the lab, though.
No eating in the lab. So you can't have the solution touching the plug. So we're just going to drain some out of this side. We should see here a centimeter gap between the solution and the plug, and our carbon electrode here looks okie dokie. So everything looks good. This one's a little bit higher.
Yeah.
Just to be consistent, I'm going to take a little bit more out of that.
There we go.
There we go. That looks pretty good.
Yeah.
For the most
Or
part.
why is it filling up more on the left? That's weird.
I think it's okay. All right, so now we're going to attach this to this guy. And what do we want to use? Probably this, right?
Yeah. I don't know. We're supposed to be using this, right?
Which one?
I think there's supposed to be two different things, so I think you need to maybe set up both of them.
Two different things.
Like two different clamps.
I see one clamp.
You only see one clamp?
Yeah.
Okay. Whoops.
Nope.
One clamp down.
Which one did you break?
Yeah, I didn't break anything.
Okay.
I didn't break anything. It's kind of a novel way to do this, eh? A live video.
Yeah. Well,
kind of fun.
we were talking about this.
Yes?
So that instead of the kids staring at you for 35 minutes as you explain everything, you just play a 35-minute video that they stare at instead.
Yeah. All right, because they don't listen to me when I talk anyway. Okay, there we go. I think that'll work. I don't know why we have two clamps. And you have it actually going around the correct one.
Yeah. I can read.
I know. Or you can see.
I can see. Okay. So, we have everything clamped up right now. As you can see, this is clamped to the iron electrode, and we have the carbon electrode here totally free. So, can you see that? Let's see if I can zoom in 2 seconds. There we go. So that's the setup right there. And we'll zoom back out. Cool. Awesome. All right, step number 6. Make the electrical connections as shown in Figure 1, but do not connect the circuit to the DC power supply at this stage, so we don't die. Okay, so connections. So basically what we're going to do, we're going to want to take our plug right here, and there we go.
I'm going to move the
So,
acetone.
sure. So one end is connected to the plug. Sorry, one end is connected to the lamp. The other end, this end, has to be connected to something. And we're going to connect this to the U-shaped electrode right here. So this gets attached to the U-shaped electrode. Insert that, screw it down. Perfect, awesome. And then this is now hooked up. And then the light bulb right here, which has been loosened so that there's no active connection. And just for everyone paying attention, and those people not paying attention, the light bulb is loosened, so it's basically not there. If you feel tempted and you don't trust your lab partners, you can just put it off to the side so that you know there's no connection and no one's going to die. Then we take the black end out of the lamp, and we connect it to the
Multimeter.
To the multimeter.
The COM part of the
Into the
multimeter.
COM part. So this right here goes into the COM connection down here. Perfect. And then
From the multimeter
from the
to
multimeter, perfect. So from the 400 milliamp connection of the multimeter to the iron part of the U-tube. So, I have to undo this. Okay, and we'll use red for this. Okay, so I guess it goes like that. There we go. Okay, so 400 milliamp from this to now the carbon
to the iron.
to the iron. Yes, the iron. So we're
How
gonna
is
go.
that connecting? Do we not need little alligator clips?
Oh, we're just gonna do this. And then we're going to twist it around. Actually, we'll just do like...
I wonder if that's what the other clamp is for. To sort of keep them?
Maybe. So, there we go. Hold on. Wait, I just had it. Good enough.
We're getting there.
Getting there. Okay, so that's one connected, loosely, but it's touching. And then the other one, we want...
From the carbon back to the... Yeah, this isn't going to work. I think we need alligator clips.
Aren't there some over there? Yeah, there are. I see them.
So you might want to take those ones out.
Sure.
I feel like, hang on.
We decided that trying to basically wrap this end around some metal is difficult, so we're going to grab some alligator clips instead.
Is this going to work?
Not really. Those ones are the wrong connections. That one will work.
That one will work, right?
Yeah.
But then I need...
So,
oh no, this will work, because this then connects from the carbon.
So that goes there to iron. Boom.
And then this connects to the coulometer to close the circuit.
And then
From the carbon
boom.
to the coulometer on this side.
Beauty.
Look at that.
There you
Teamwork. That's why you work in partners.
Okay. So, just to reiterate, we have the plug, and from the plug, we have the red wire that goes all the way to the U circuit of the electrode, and then from the U circuit electrode, we go through that to the black lead. Black lead goes up to the carbon. Through the carbon, it goes to the iron. From the iron, down into your multimeter. From your multimeter to your light bulb, and everyone is happy and hunky-dory. Perfect. Okay. And now, have your apparatus improved by an instructor. Look good, Ingrid?
I think it looks good.
Okay, perfect. So, we set it up. We think it looks good. If this explodes in 20 seconds, it'll be cut out of the video, and you won't see it anyways. So, unscrew the lamp bulb, which is already unscrewed. Close the circuit by screwing in the lamp. And when do we plug in?
Well, we should probably plug in now. So it said that plug the red lead into the far. Oh, okay, we already did that. So I think we're supposed to plug into the.
So it doesn't say where to plug in.
But do not.
So
that's after the instructor. So now we can plug in.
Okay.
Because I've been.
So now we plug it in.
And that's the DC.
So plug that in. Check your wires to make sure no one's going to die.
Because we have to set the timer to start. So double check that the timer is
screw
going to
in.
start properly, because we need the time so that they can calculate the the amps.
Okay.
So the Q.
I'm going to hit. So this is an example where you're going to read ahead and make sure that you're ready for this. Close the circuit by screwing in the lamp and simultaneously starting the timer. Boom. Note the various effects of passage of the current and record your observations. Okay. So your lab partner is going to hold the timer.
Okay.
And they're going to hit start as soon as the light turns on.
And hopefully the light turns on.
And hopefully the light turns on.
Because it's kind of our switch and indicator that the circuit is complete. See? Started the timer.
And I have to unscrew this in 30 minutes?
Yeah.
It's already hot.
Is it? Oh, I guess I'll get you some nice, hot protective gloves.
Perfect. Okay, so now we
want to look at at
cool.
observations.
So, let me get the camera for this part.
So first of all, the light bulb turned on, so we know that the circuit is closed. We're not seeing anything in the coulometer, but we are seeing something in the U-tube where the electrolysis is occurring.
So we're seeing, let me get it to focus.
So the carbon electrode has bubbles forming.
So it has small tiny bubbles forming, and
Okay.
the iron electrode is generating a lot of milky bubbles. So right off the bat, things are working. And if I can zoom in really into there.
So hopefully you can see what's going on. And I think we have to let this go for like 30 minutes.
Yeah. So you can see here bubbles coming off of the carbon one. See if I can get really in there. Oh, it doesn't like that. There it goes. So there's the carbon electrode, and that's generating a lot of very, very tiny bubbles. And then there's the iron electrode, and it's generating a lot of very, very tiny milky white bubbles. And at this point, you'd be writing all this down and making great observations. Cool.
So gas is being formed. Think about what gas might be forming from the sodium chloride solution.
I think the copper's doing something too.
Is it?
Maybe not. No, I was looking the wrong way. Okay, so now...
So at some point we're actually going to test the gas that is coming out or is being produced from the electrolysis. And if you might, one thing that is interesting is that the stoppers are not completely filling the opening of the U-tube, because if they were, then there would be no exit for the gas bubbles that are being formed.
And you'd make a bomb.
Yes, you would. Well, it would just, the apparatus might explode, which would be bad.
Which is a bomb.
And dangerous. Yes, I guess that's a bomb.
Okay, cool. So we will come back in, what, 30 minutes?
Yep, 30 minutes.
Okay, cool. Okay, so we're back. It's been a little over 30 minutes, so we're getting ready to basically deconstruct this and break it down. But first and foremost, we have to make sure that we're testing for any kind of generation of chlorine gas. So we're going to move this guy over here, and we're basically going to hold a test strip over the edges of the two sides of the U-tube to see what's going on. So you should be taking your potassium iodide paper, which is right here, and you're going to...
Potassium iodide starch test paper.
And then we're going to wet it down. He's just using a DI bottle.
Need 2 test strips. So this one's not doing anything. So nothing on the test paper based on the gas that's being formed on the side of the iron electrode. And then on the side of the carbon electrode,
oh, cool.
Instant black. Very cool. Should we see that again?
I think so. Do just the
just the one side.
Just the carbon one.
Yeah. Okay, ready?
Yep. Cool.
Okay. The other thing of note.
Whew, it does smell like a pool.
Yes, it smells like, right now, it smells like chlorine, like bleach in here.
Yeah.
Like a swimming pool. The other thing, we had to change our fluke meter. It died, but it has been consistently reading, well, it was 208.1.2. So
it's advised to make sure that you guys check the battery level of your fluke beforehand to make sure that it's going to be working. And one thing that it might say if it's not working, if you switch it to the setting, it might tell you, it might give you a battery error. This one did before, it might not now that it's not drawing current.
Great equipment.
But yeah, so just make sure that everything is all working, and we'll make sure that the batteries are all charged beforehand. So let me pop out the screen so I can see what the hell's going on. Cool. All right, so we're back. Now we're looking over here, and we're looking at, after electrolysis has proceeded for approximately 30 minutes, break the circuit by unscrewing the lamp and simultaneously stopping the timer.
You need something to...
Disconnect your circuit from the DC outlet. Okay, so our timer is at 33 minutes. We've gone a little bit long. Ingrid's going to grab us a thermal glove to grab the light bulb and basically unscrew it. I guess, Ingrid... Yeah, we have it here. We can also probably break the circuit just by unplugging the multimeter.
We could.
If we needed to.
Yeah. Okay, so what time are we doing it at?
So I'll unscrew it when it hits 34:30.
3430.
Yeah, so it's 34:15 right now. So it hits 34:30, I'll start to unscrew it. So there'll be a second or two delay. Whew, it's a hot glove. Or it's a hot bulb. Okay. So bulb is unplugged. Our milliamps have gone down to 0 because we've broken the circuit. Our bubbles have stopped generating almost immediately because there's no more power going through. And the timer has been stopped.
Excellent.
Okay, so
Now we're on to
step 13.
disconnect the DC.
Immediately remove, and unplug. Immediately remove the electrodes from the electrolysis cell. Set the carbon electrode aside and place the iron electrode in one of two clean 150 milliliter beakers. So by electrodes, it means the carbon and the iron electrode. So we're going to unplug these guys. The carbon we don't care about, so just going to put it down off to the side over here. And the iron, whew, it smells like a pool big time.
Giving you two fresh beakers.
Perfect. And the iron one, we're going to very, very gently place into this guy right here. Now note, I took the iron out of this one right here. I'm now going to basically hold a hand onto here because I want to pour out the iron solution into the beaker that has the iron electrode. So I'm holding it like this. I'm now going to basically lower this down to the two beakers, and away we pour. And everything should come out, and we should be off to the races. Now you might note that you'll see some white crystals everywhere on your glassware. This is on the outside of the... Oh my god, it reeks of pool. Whew! Jesus. I worked in a pool for 12 years. This... Oh my god. It smells like someone injected... Oh, Jesus. So this is going to reek like just absolute awfulness. This is like chlorine gas. Like it's basically mustard gas almost. Like,
yeah, exactly. But we have to rinse that out, I think,
whew!
right?
Jesus. Yeah,
You okay?
I'm trying not to
Do you
get...
need some fresh air?
I'm trying not to get dizzy. I like
You
inhaled
need some
it.
fresh
No,
air?
I'm fine.
Okay. Here's the
It'll keep all the bacteria and viruses away.
Yes, exactly.
Just disinfect my nasal cavity. All right, so dun 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 dun. Place two beakers side by side. Pour out. Dun, dun. Wash out the hydroxide arm of the U-tube. So basically, this guy right here with the aluminum, with three 10 milliliter portions of DI water, adding the washings to the beaker. So I'm basically just going to use this DI bottle right here. And I'm basically just going to spray down this side and pour out once. I'm just going to do this a few times. Because we're calculating moles, it doesn't matter how much water you add to this. And it does say 10 mils, so I'll use a lot for this last little one right here. But really all you want to do is you're just rinsing out all the hydroxide. You're just getting rid of all of that. Now, one source of error to keep in mind, if we look right here, on both sides of the plug right now, I have no solution. But as I add water, the water is going to slowly penetrate through the plug and add water to this other side right here. Therefore, when you're doing this, you don't want to have it sitting upright and having water go through the plug like this. I'm showing this because I've already rinsed it out. But you basically want to make sure that you're holding this at an angle like this so that no water goes through the plug and you're just rinsing everything out. Because it is a semi-porous plug, so water will still go through as a function of basically the headspace of the water. Oh, look, Umbrine's here. Umbrine's going to walk in and say hi.
Come on in.
Never mind. No, she's not.
PPE, so.
That's okay. Ingrid wasn't either.
Okay.
What do you mean? I'm wearing
joking.
PPE.
Okay, so step 16. Lift the iron electrode slightly above the solution and rinse it with a stream of DI water from the wash bottle, again allowing the washings to run into beaker 1. So we're basically going to lift this guy up and basically just spray all the hydroxide down. If you do it really cool, you can see all the water run down because of surface tension. Okay. So that's all rinsed. Set the electrode aside. Done. Beaker 1 now contains all the hydroxide ions formed during electrolysis. Add 3 drops of bromothymol blue to this beaker and then titrate the hydroxide solution using a burette filled with standard HCl solution. So we're going to fill up the burette with HCl right now. And I'm going to take this beaker one.
The HCl is a standard solution of HCl at 0.1000 moles per liter.
Cool. And
make sure that our burette is actually closed. Where did I put the funnel? Take the burette down. Oh, it does stink over here.
yeah, it reeks. It reeks of a pool.
I'm actually going to rinse this out. Still recording?
Yep.
Okay, so just so you know, what I'm doing now is I'm actually rinsing out the burette with the HCl solution like we have always done during titrations. Hi. Thanks, David. You're really close. There are still people around, but not really. Is this for first year camp?
Yeah.
And I'm going to run some through at the bottom as well. Are you going to be here for another hour? Yeah. Do you know where the DNA sequencer is? I'm going to close the burette, and I'm going to fill the burette now.
Wrong one.
Does it matter? Oh,
Well,
right.
I'm set up.
Yes, you're set up. My apologies. Okay, but we don't want to use that yet. We want
No,
to use
you had
an
bromoethanol.
empty beaker. I'm just going to run some through so that we have no air bubbles. And then we're going to read Do you want to do the reading?
Sure.
So we need to mark down the initial volume of the burette.
Where are we? There we are. Okay, I'm seeing 2.7, it looks like.
You need 2 decimal places.
2 points. Hold on, you put the camera down. 2.60.
2.60 milliliters.
Correct.
Okay, so you're going to put the titration thief.
Are we teaching them how to use this?
The what? Yeah, this
Sure.
is part of the lab, so that because we're going to go over. So this thing is called a titration thief, and we're going to use that to help us along with the titration so that we don't have to do it multiple times. So basically you're going to use it to suck up or remove some of the solution from the beaker. I would fill it up more than that, like as much as you can. Is that all that's coming?
That's all I got.
Okay, so that's fine. So basically you're going to fill as much as you can in that
Just keep it in there?
and keep it in there, and you're going to titrate everything else. And so when we go beyond the end point, we have some to put back in to bring it to the exact end point.
Perfect.
Pretty cool. Okay, so we need the indicator.
Yes. 3 drops bromothymol.
Bromothymol blue, which indicates a pH of between 6 and 7.6.
It's really stuck in there.
And while he's doing that, I'm going to just show you that my results. I don't know. if
We'll
that
show you
can
after
work.
so that
we'll
you're not-
show you after, but
Because
anyway.
I'm zoomed in.
Yeah, no, that's fine. It's working. So basically, I took the milliamps every 3 minutes while it was actually working. Oh.
Okay, 3 drops. Okay, and we're looking to go from blue to yellow. So if you're starting at blue, you're on the right track. If you're at yellow, you screwed up. Okay, so I'm going to adjust this, and so if you want to be really advanced, what you can do is take a small amount of it, titrate it first, figure out how much it took to titrate that small amount, and then work back to titrate the whole thing. Because I've got no idea how much this is going to need. So it might be 10 drops, it might be 100 drops, it might be 1,000 drops.
And I don't know either.
Yeah, and Ingrid doesn't know either. And Umbreen knows, but she's not telling us. Will you be TAing next year, Umbreen?
Let me, yeah.
So if you guys see Umbreen watching this video, this is the point you can turn to her and wave, or she'll wave at you. If it's 2 or 3 years from this video, so if it's 2022 or 2023, and Umbreen's here, you can turn and laugh at her, because she said she'd be gone by 2021, and she likes to lie to people.
I'll be here though.
Ingrid will be here.
Yeah.
Hopefully.
You'll be here.
Yeah.
If she isn't,
If
I'll
I
be here.
survive the pandemic.
Yeah.
I'll be here forever. I'm never leaving.
Yeah.
We can keep this video as historical evidence of COVID-19.
What you went through.
Well, let's clarify. It's like the first day of the shutdown, so that it's not like it's like day 30 and like Kingston's like burning down, and we're here and we're here making light of it.
They're thinking about
But
shutting
it's
down.
pretty incredible how empty the shelves are in the grocery stores from toilet paper. I really don't understand. I think the problem is that people are under the assumption that paper products come from China. They don't. Our toilet
They
paper
can't
comes
think
from,
that.
No.
Well, then why are they buying toilet paper
It's like
the way
this.
they are?
One person sees
I know.
decides, I want to buy toilet paper. The other person sees, why is that person buying toilet paper? I need to buy toilet paper.
Yeah.
I should go and buy toilet paper.
Well, it's
Then
the
another
whole
person
thing.
sees
Yeah,
two people,
it's
and
the
then
whole thing of the
totally
fallacy of the
goes
common ground. It's like if everyone plays nice, there's more than enough resources for everyone. All it takes is one person to take more than their fair share, and then everyone else panics and goes, well, I need to take more than my fair share so that I have some. And then people have nothing. Like, people are buying so much food, I guarantee half the food's going to be thrown out.
Yeah, which is kind of sad. The other thing that's interesting is that they've been saying that at the Costco parking lots, that when people come out with toilet paper, like when it was an issue, now they've sort of limited it to 2 packages per cart. Not per customer, per cart. So you can walk through with like 4 carts and get 2 packages in each cart. But anyway, people were bartering.
Oh, yeah,
with
I heard
people
that.
in the parking lot.
Really?
Like, I'll give you this stuff if you give me one
the
of your
States?
packages of toilet
No,
paper.
here in
I
Kingston.
think it was here in Kingston.
No, because
Yes.
I went to Costco on the weekend and said 2 per
Yeah,
person.
this is before. This is
Oh.
Thursday and Friday of last week before
Oh.
this all.
I went on Saturday, so
Yeah, I went on Sunday and got some toilet paper, but we actually needed toilet paper.
that's the worst. Like when you actually need it and people are looking at you like, "Why are you buying toilet paper?"
Yeah. Well, because I actually
I
need toilet paper.
No. Yeah, we have some, so we're good.
Oh, I should record the molarity of the HCl that was used. I'm gonna write all this down.
Yeah.
So if I haven't edited this out, I'm basically just speeding up the drops.
It's okay.
There's a lot of hydroxide in this. Jesus.
Yeah. So basically, we are trying to measure the amount of hydroxide in moles that was created through the electrolysis of the sodium chloride solution. So what's the point of this lab? You're going to be able to calculate Faraday's constant using all the results from this lab, and then you'll compare it to the actual Faraday's constant, which is what, 96,487 coulombs per mole electrons.
Oh, I'm just stretching. This is where my trick would have come in play.
Yes, and not only that, it would have been easier in an Erlenmeyer, but that's not how it's mentioned.
Yeah. We didn't do this last year, did we?
Yeah, we did.
This one? I'm gonna be in somebody's report from last year, how much they used.
Oh yeah, I guess I could have looked at that.
Oh well.
Okay. Are you gonna do this for the rest of the labs?
Just one more.
Just one more aspirin.
Right.
Holy moly.
That's a lot, eh?
We're adding a
Hopefully
lot.
We don't run out.
Well, that's the issue I'm worried about.
I wonder
Like,
if
we might
went
either-
too long, right? Like we did it for 33
It's 33 minutes. We went 10% longer.
Oh, we're getting there?
We're getting there.
It's looking green rather than blue.
Well, it means the yellow's showing up.
Yeah. Oh, there you go.
So that was very quick. That was a quick end. So now we add this guy back in,
And hopefully there's enough in there.
and hopefully there's enough in there. Okay, so this is clear, I think.
It's got yellow tinge.
Barely yellow tinge. So that's pretty much the end point. So we'll record this. We'll add a few more drops just to see how much more yellow it goes, and we'll call it there. So this right now, I'm reading 43.85.
43.85 milliliters.
And we started with 2 point something. So this is about 40 milliliters we had to add.
Yep.
Good to know. So let's add a few more drops, see what happens.
I have a feeling we went past the end point.
I think we're okay. Okay. So we overshot it a tiny bit, but that's okay.
Yeah.
All right. So we're good?
Yeah.
Awesome.
Good, but now we're not done, because now you have to take apart the coulometer and you have to measure the mass
Perfect.
change in the electrodes.
And we have to dry those too, probably, right?
Yes.
Okay.
So we're going to have to move things out of the way, paper products, so that we don't cause a fire.
Oh, we have to dry with acetone?
Yep.
Okay. Yeah, Ingrid set the countertop on
Yeah, I
fire
did.
last time.
Come on. It was you.
It was me.
Funny.
You were like, that looked really cool. Do it again. The camera's behind you. Watch out.
Batteries.
And just as a heads up, like, the stuff is pretty cool. Like the pH, sorry, not the pH, the iodine test paper, or the potassium iodide test paper. The
Yeah,
way it
that was pretty
turned.
cool.
I don't know, that was pretty.
I'd probably almost say do it at the start and do it at the end, and see how much more quickly it turns.
Yeah, maybe.
Okay, so sparker.
You want me to do it?
I can do it.
Okay.
Before you light my face on fire.
Yeah. And maybe move the acetone out of the way, since it's flammable. Oh, that was faster than me.
Yeah. Freaking me out with it. Okay, we'll disconnect the electrodes.
And we don't want to be touching them, right?
No, because we might scrape something off. Oh yeah, yeah, you can see it.
So let's show observations. So what are you seeing, David?
Okay, so I see. Hold this up to the camera. You can see the different color in the copper plates.
So which one do you think
So the middle one looks like it got.
more copper formed?
It looks like more copper formed, although it could be that it's. Yeah, it looks like more copper formed. It could also be that the copper ions are coming off of it and giving it this nice shiny patina, but yeah, it looks like that more copper's formed onto it. That's the idea, right? It's
Yep,
basically-
which means that the outside ones will have lost mass in copper.
Correct.
So that's our prediction. Let's see what actually happened.
Cool. So let me.
I would rinse with water first, or no?
You can do that. So rinse off with water. Very, very lightly. We don't want to brush off any stuff that we need. And then acetone. Okay. Now, we're going to shake this off a little bit so that the thing doesn't catch fire in my hand.
It might have been a good idea to take them off. The lid.
Should we take them off?
I would think so.
And then put
Do
them
them
where?
individually?
Well, here, we'll let
Or-
it dry off quickly
okay.
and then just give it a little... Actually, let me hold it like that. So we're just passing this over the flame just to really, really dry them off. Because really all you want is the heat. You don't need the fire, you just need the heat.
That's probably good.
Okay. Okay, so that's good. Now we're going to take these off and weigh them one by one. So, do. Awesome. All right.
And then we'll see what number each one is.
If the number stayed on.
I hope so.
Yep, it did. Perfect.
So that's number 3.
Number 3.
Is it completely dry?
Yep. Taking a look. Yep, completely dry. Okay, so number 3, going on.
Number 3 was originally 12.9830.
So it's now 12.9019.
9019.
Yep.
Excellent. So it lost about 800. 0.08
Okay,
of a gram.
let's do the far one.
Which should be number 1.
Should be number 1. Okay,
So
number 1. Make sure it's all dry. It's not
It
dry.
was 11.4735.
Yeah, it's not dry. I'm just going to wait 2 more seconds. Just make sure the acetone evaporates off. I'll just hit it with the flame quickly. Okay, number 1.
It was 11.4735.
11 point what?
4735.
So it's now 11.3955.
3955.
Yep. Okay. And last but not least, middle guy. Our hypothesis is that this gained copper.
Well, the other 2 lost, so let's hope.
Let's hope it gained.
Yeah.
Okay.
Is it dry?
It is indeed dry.
It was 13.9964.
It was what?
13.9964.
So it's now 14.1381.
1381.
Correct. Sorry, 14.1384.
14.1384.
So it gained. Cool.
And I think that concludes the...
And now, if you've been doing all the work, you now turn to your lab partner, and they clean up everything. Hope you guys enjoyed it. It's pretty cool. Don't light yourself on fire. Don't inhale the chlorine too much. And, yeah. Bye.